All right, take two. I had a bunch of announcements during the last one, so we're going to try it again. We're going to try to squeeze in a bunch of stuff, a lot of review, a few new things, including some advanced look ahead here. So first of all, our most basic rule is we've got what's called a central angle here. We know this has got to be what? That's right. It's got to be the same. It's got to be 60. This is 60. That's going to be 60. And once again, this is our central angle because it is coming from the center. Down here, we have what's called an inscribed angle. Inscribed angle, vertex is on the edge. If we know this number is 50 degrees, this arc here has to be double. Or if I give you this, we know this angle has to be half, no matter where it's coming from. It doesn't have to be coming from here. It can be coming from, here over to there would work. This right here, I just call this an interior, and I might call it an interior not central because it's not in the center. The center is M. We know these two angles are 10 and 150 degrees because I tell you they are. And the way we find this angle right here is we add those together and we divide by 2. So in this case, that would be what? That's right, going to be 80. And then finally, when we got what I called an exterior angle here, the exterior angle, this arc here is 150, this one here is 30. In this case, instead of adding together and dividing by 2, we subtract. So that right there is going to be what? That's right, 20. And the point I like to make is if I'm coming from the center, see how this is, if I'm coming from the center, see how this is 60 here? Well, as I get further away from the center, this becomes less and less all the way down to 30. So as I go further away, it's got to be even smaller, but more importantly is if I'm somewhere that's not in the center but over here, well, it's got to be, we know it's got to be less than the 60 that it was in the center, but more than the 30 than it was inscribed. So this is why this right here works, is because, well, it's got to be somewhere, like if 150 was in the center, it'd be 150, but as I move further away from the center, it'd go all the way down to 75. So this in the middle somewhere has to be somewhere between the 150 and the 75. All right, enough on that. Couple of new things. A tangent. So this right here is a tangent line. It connects at exactly one point. If I happen to connect it to a radius, so this is a radius here, AC is a radius, this will be 90 degrees. It's a definition, or it's a property of a tangent, that when it connects at one point, if it touches a radius, that will be 90 degrees. Well, what's interesting about that is like, well, if I extend this on out, we know that this side of the arc is 180 because that's a diameter, and this side is 180, which is a diameter. But notice that is 90 degrees. Well, that's our inscribed angle rule, because this is really just an inscribed angle. Over here, kind of a similar situation, except I don't have I've got what I think is an inscribed angle, but it's definitely a tangent. So maybe if I told you this over here was 120 degrees, well, this major arc out here, this thing's got to add up to 360, so it's going to be 240. But then like, well, these two have to add up to 180, so I guess this has to be 60 because it's inscribed, and this has to be 120, and notice that all works out. This adds up to 180, these add up to 360, and this follows the inscribed angle rule. Similarly, tangents follow this rule when we've got an exterior angle. So maybe if this right here was, I'm going to say 100 degrees just to make it easy. If that's 100, that means this major arc here has to be 260, which means this exterior just follows the same rule. I'm going to subtract my arcs, my 260 minus my 100 divided by 2, and that's going to be what? That's right. It's going to be 160 is going to be 80. Okay. So this is not quite to scale. That doesn't quite look like it's 80, but I made up the numbers to be easy to work with. All right. One of the more difficult things you've done in class so far is doing what's called a chaser here. Now, I've written a bunch of numbers in ahead of time. These are ones I've given to you, and you've got to find out everything else. So one of the tricks people learned is these all have to add up to 180 because I've got a diameter. So this missing arc here, we know it has to be, oh wait, I've got it written down somewhere. not that. Has to be 60, okay, because these all add up to 180. Let me double check that. Yeah, that's right. Okay. Then some things might just jump out at you. Like for a lot of students, this one right here jumps out. They're like, oh, inscribed angle. This has to be 20. For others, what might jump out at them, especially if they've got the 60 over here, it's like, oh, this arc here is 80, which means that's got to be what? That's right, 80. And they're like, oh, if that's 80, this has to be 100. And if this is 100, oh wait, I could tell it's 100 that way too, but if this is 100 over here, I'm like isosceles triangle. So I got 80 to split between those two, they're both 40. And at this point, we've kind of run out of most of the easy ones. I think the easiest one that's left is 8 down here. I got a 10-degree angle and a 20-degree angle, and our rule there, once again, is we add those together and divide by 2. So that's going to be 15 degrees. But once I find that, I'm like, oh, straight line. So this is going to be 165 is 9. And then what's left here is I've got another one. I've got this angle 6 here, which is going to be these 3 angles added together to there, those 3 arcs, because that's that part of it, plus the 30 back here divided by 2. So I'll let you figure that out. And then also this angle out here is going to be from B all the way around to G, because that's that arc, minus this divided by 2. So that one right there, if I add all those together from B through G, I believe those add up to 160. I minus the 50, and I divide by 2, and that ends up being 110 over 2, or 55 degrees. That's 55. Similarly, that's how you would get 7. That arc right there, which I have not figured out yet, if I add up all those, or add up the whole circle, it's got to be 360. That one missing arc, I think, is 30 degrees. And then finally, do the same thing. 7 goes from C all the way around to H. That's that major arc there. I'm going to subtract that minor arc back here, and it ends up being, I think, 180 minus 30 over 2, or I think that's 75. Okay, I got a few minutes left, so I'm going to do some new stuff. Some new, kind of old. First of all, big review. You should know this. Area of a circle. You should know, actually, let's back up to circumference. First of all, you should know if radius is 5, diameter is what? That's right, diameter is equal to 10. And one of the reasons, the way I like to remember the rules is you should be able to intuit that the circumference of a circle is diameter, 1 diameter, 2 diameters, 3 diameters, and a little bit more. And this is actually where our 1, 2, 3, 3.14 comes from. The relationship pi comes from how many times does it take to get a diameter around the circle? And it's a little bit more than 3. And for those of you who've had me all year, you know that sometimes I'm fine if you just use 3 as an estimate for pi. Because if we're just trying to get an estimate, 3 is fine and it's easier to use. So diameter times pi is our circumference. So in this case, it is 10 pi. Or it's about 30 as a very rough estimate, or 31.4 as a slightly better estimate. That is still approximate, because you're using 3.14 as pi, and pi is much longer than that. It goes on forever. It's irrational. So all 3 of those numbers that's an exact number. Those are good estimates. Area. So this is one of the reasons I like using diameter, is because you need to remember, oh, the other one uses the radius. In fact, I just noticed R for radius. And we know it's going to be in square units because it's area. So pi r square is our formula for that. So in this case, we know that 25 pi is the area. That's the exact area, 25 times pi, 5 squared. Or if I want to do a quick estimate, 3 times that is 75. Or if I want to get a calculator out and do it longhand, it's actually 78.5 if I use 3.14 as my better estimate of pi. But once again, 3 will get you close, and it's easier to figure things out, especially if you're doing multiple choice tests. Okay, I'm almost done. So here's the one kind of new thing. It's what's called a sector and an arc length. Okay, so first of all, this is not to scale because this is 5, this is 10. I just use that because it's an easy number to use. Immediately, diameter is what? That's right, 20. So my area for this thing, or actually do circumference first. My circumference is going to be 20 pi, or a little bit more than 60, 3 times that. My area, let's see, r squared, that's 100 pi, or about 300, or 314. I'm being a little more precise. Okay, sector area. Sector is this stuff. I'm saying I've got a 60-degree sector. Sector is like a slice of pizza, okay? So it's 60 degrees. I want to know what the area of that is. Well, it's that portion of the circle. So there's 2 ways to do this. You can either set up a proportion and say, well, 60 out of 360 equals that portion I don't know to the total area is 100 pi, or in fact, I'm just going to use 300 as a very rough estimate, but it'll be easy to figure out. I want you to take a moment and figure that out. That's right. If I use 300, x equals 50. The other way I could have done that is I could just say, well, my total times my fraction will work too. It's the same math. Similarly, to find the arc length, now we know this is 60 degrees, but it actually has a length. I could put a string along there and measure it, and it's all related to how long the diameter is. So in that case, same math. I know 60 over 360 is my portion of the circle. My entire circumference is 20 pi, or roughly 60, and then the lights went out. And I got them back on again. That was weird. Sorry, this is going a little long. And I am trying to figure out what portion of that it is. Well, that's actually pretty easy to figure out. I'll give you a minute. That's right. It's going to be, it's 10. Yes, it is 10, because 60 over 360 is the same as 10 over 60. All right, that's enough. Sorry, I went a little long. Bye.